Hello everyone, we're from group 26. My name is Kim Shin, and today's presentation is about the linear search and bubble sort. Okay, so now let us begin. Today's content include linear search definition, some example and flowchart, both advantages and disadvantages of using linear search, and its summary. In the second part of the presentation, bubble sort definition, some example and a flowchart using the usage of bubble sort and advantages and disadvantages will be discussed. I'll be taking over the first part of the presentation, which is linear search. So what is a linear search? It's a method of finding an element within a list. The list can either be an array or an array list. The search begins from one point and gradually goes through each element of the list. It will continue until a desired element is found or the list has simply reached its end. Here, searching for a name through a phone book or an address book is used as an example. Imagine picking up the nearest address book and look for the name Sam. We will look name by name from the start till we find Sam or until we reach the end of the address book. This is a brief pseudocode for the linear search. First of all, for all elements, it's equal to the element being searched for. If yes, then return the position of that element. If not, continue the search. The search will continue until the element is found or the list is completely searched. This is a very easy example for linear search. So there's a list that contains 5 elements. In here, they are 5, 4, 3, 2, and 1. The goal is to search for 3. We go through the first element in the list, which is 5. Is 5 equal to 3? Apparently not. So we go to the second one. The second element in the list is 4, but 4 isn't 3 either, which we're searching for. So the next one. Finally, in here we found 3. Consider this is an array. Then we can say 3 is at index 2. So the next part of the presentation will be presented by my friend.
In this Java example, in the class linear search, we find the element with the for loop, whether there is the element we are looking for is in the array. If there is the element, it returns the index. If there is not, it returns -1. In the main class, it will print out the output. It will print the output 3 is found at index 2. This is the closure example for the simple linear search. In time complexity, the linear search algorithm is a simple and straightforward way to find a target value in a list. It has a time complexity of O n in the average case. O1, the best case is the O1, and the O1 in the worst case, where the n is the size of the list. It has the worst case amount time complexity. And the next part is advantages. Linear search is easy to understand and implement, and it does not require any special data structure or extra memory. Additionally, it can be used on unsorted data, unlike some other search algorithms that require the data to be sorted beforehand. And here comes the disadvantages. However, there are some disadvantages to use the linear search algorithm. Firstly, it can be time-consuming, especially for large data sets, as the search time increases with the number of elements. Additionally, it's not suitable for repetitive tasks or for searching through sorted data. To summarize, the linear search algorithm is easy to work with, and it can find a target value in a sorted way. It works fine for small numbers of elements, but the search time can become inefficient for larger data sets. It's not suitable for repetitive tasks or sorted data, but it can be used on unsorted data.
So I'm going to present about the bubble sort. bubble sort is one of sorting algorithms. It works by repeatedly comparing each pair of the adjacent elements. If they're in the wrong order, we will swap it. Right? It can be both ascending order or descending order. So I'm going to show an example of an ascending order. First of all, we will compare the first two adjacent elements. Because it is an ascending order, if the first element is greater than the second element, we will put it in an empty variable and put the second element to the first element place and the temporary element to the second place. And for the next pair of elements 9 and 8, we will do the same thing. Also for the 9 and 2 and 9 and 7. So we will also compare again, starting from the first two pair again. The first element 1 is not greater than the second element, so we will skip that and go to the next adjacent elements 2 and 8. Oh, sorry, 8 and 7. This is the Java code of the example I mentioned above. In the first half of the code, it is the main method. We will have an array and the for loop for printing out. And we'll call the bubble sort method here. In the bubble sort method, we will have the two for loop and we will have the if condition. If the first element is greater than the second element, we will put the first element in an empty variable and we will swap the place. It is for the ascending order. If we would like to do a descending order, we can change the array of j less than symbol here. Yeah. That's all for my part. And my friend Nang Ying Lao Sai will present the next part.
Hi, I'm gonna be show you and explain you briefly about the pseudocode of this bubble sort. This is a different method from what my friend Vivi has explained. And let's go to the first line. And this is the method that we will return the array. We will use the array back and is the length of the array. We will use the first loop for the iteration of each element in the array. And we set the swap condition to false so that we will know if it is swapped or not. And this pseudocode we also use the nested loop, and in the inner loop is j from 0 to n minus I minus 2. In this condition, I would like to explain you a little bit about how it is b n minus I minus 2. The reason is that the loop range being 0 is in each iteration of the outer loop the largest element of the unsorted portion of the array bubbles up to the end. So in the next iteration of the outer loop, we do not need to compare the last I elements of the array since they are already sorted. Therefore, the n minus I minus 1 element is the last element that needs to be compared with its neighbor in each iteration of the inner loop. But since we are assessing j plus 1 element in the inner loop, the inner loop range should go up to n minus I minus 2. If we have an array of length 5. In the first iteration of the outer loop, we need to compare elements at index 0 and 1, 1 and 2, 2 and 3, and 3 and 4. In the second iteration, we only need to compare elements at index 0 and 1, 1 and 2, and 2 and 3, because the largest element is already at the end. Therefore, the inner loop range is adjusted based on the value of I in each iteration of the outer loop. And after that, if we finish the loop inside this, the swap is turned to true, and we break this loop. And for this, if not sorted, if there is no element to be sorted, then the outer loop will be break, and we return the array. Next slide, please. And this is a flowchart which symbolizes the method in which we explained earlier, so I'm not gonna talk about this. And next slide. And this slide is the time complexity of the bubble sort. The average case is 0 and 0 O n square. Worst case is O n square, and the best case of it is n, which is the size of the list. And the next slide will be presenting by my friend Nokukutu.
In this slide, I will be talking about bubble sort usage. Bubble sort is a simple sorting algorithm that can be used in various real-world scenarios, where a small to medium-sized list of items need to be sorted. Here are some examples. Sorting small data sets. Bubble sort is useful when you have a small data set that needs to be sorted, such as a list of customer names, phone numbers, or addresses. It can be used to sort items alphabetically, numerically, or by any other criteria. Sorting data in spreadsheets. Bubble sort can be used to sort data in spreadsheets such as Microsoft, Excel, or Google Sheets. For example, if you have a spreadsheet with a list of sales figures, you can use bubble sort to sort the data by sale amount, customer name, or any other criteria. While bubble sort is not the most efficient sorting algorithm and can be slow for large data sets, it can still be useful in sorting real-world applications where the data size is small or the sorting operation is infrequent. Here, advantages. Bubble sort is a simple and easy to understand sorting algorithm that can be implemented without any difficulty, and this makes it an ideal choice for those who are new to programming or sorting algorithm. Secondly, it does not require any additional memory space as it stores the input array in place. This means that it can be used in situations where memory is a concern. Thirdly, bubble sort's adaptability to different types of data is another advantage. It can sort data of any type, whether it be integers, floats, or strings. Lastly, bubble sort is a stable sorting algorithm, and this means that elements with the same key value maintain their relative order in the sorted output. This can be useful in certain scenarios where maintaining the original order of equal elements is important. And disadvantages. Firstly, while bubble sort is a simple algorithm, its time complexity is high. This means that it can be slow when sorting large data sets, making it unsuitable for many practical applications. And secondly, bubble sort is not suitable for sorting large data sets, and its performance decreases as the number of elements in the data set increases. And it may not be able to handle data sets with millions of elements. And lastly, bubble sort is not a stable sorting algorithm, and this means that the relative order of equal elements may not be preserved during the sorting process. In other words, if there are two elements with the same key value, their order in the sorted output may not be the same as their order in the original input. This is the end of our presentation. Thank you for listening.